Good day, folks. Welcome to Brett's Mind Academy. Now let's deal with the last part of this question paper, the off. Okay. Now electroplating. Okay. Now the simplified diagram below represents the cell used for electroplating ornaments with silver. Okay. P and Q are two terminals of the battery. Now remember from the multiple choice question I said what we are trying to do, we do it on the, if we are trying to form something or electroplate something, remember I even did an example of a spoon on question one. Whatever that we are trying to form, we form it at the cathode. So it means this one is the cathode. This one is the cathode. And that one is the anode. And now remember I said, unlike galvanic cell, in galvanic cell the cathode is positive, the anode is negative. But in the electroplating and the electrolytic cell, where we have a cell, the signs are opposite. So it means here it will be minus and that one will be plus. It means here we'll be having minus, 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 minus. Here we'll be having plus, 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 plus. All right, yes. Now, what are we trying to do? We are trying to electroplate this ornament with what? With silver. So it means these silver ions will go here to the negative terminal or to the cathode, and they will do what? They will gain electrons and they will form what? Ag. So here they will form like Ag here. So the mass will also increase here. Okay. This is what is going to happen. Let me take this reaction. Okay. This is the reaction that is going to occur in there. Okay. And remember the terminals here, it is negative. This is, let me do this. This is negative, this is positive. Okay. Yeah. Then I want to see anything that I might leave out. Okay, good. State the energy conversion that takes place in this cell. When you see a cell, a battery like this, so just know it is from electrical. But unlike electrodynamics in paper one, where we convert from electrical to mechanical or kinetic, we convert to what? To chemical in this case, because we are dealing with chemicals. Chemical, not chemicals. Okay, yes. Which terminal of the battery, P or Q, is negative? I've already answered that. P is positive, is negative. Write down the equation for the half reaction that takes place at the cathode. Cathode, which one is the cathode? Cathode, you have to identify. Here is the cathode. What is the reaction? This is the reaction. I've already answered that. Now, calculate, this is very interesting. Calculate the current needed to electroplate the ornament with this one. Remember, at the end of the day, how do I calculate current? Current is equal to Q divided by change in time. I'm given time. Current is what I'm looking for. How can I find charge? Okay, now I'm given what? The mass. Okay, I'm given the mass. And now what I'm dealing with, it is silver here, right? Remember, I'm dealing with silver here. So I can get the number of moles of silver. Okay, I can say the first step that I want to do. Here are the steps. The first step, get the number of moles of silver. Okay, then second step, compare number of moles of silver with the number of moles of the electrons, the number of electrons, because at the end of the day the current is, we get them from the electrons. Okay, then what will happen? Find number 3. Find, this is the number of moles of electron, but we want the exact number of electrons, so we're gonna get them from here, calculating n by using this formula. N is equal to n divided by Na. Okay, this is the number of moles of electrons. These are number of electrons, the exact number of electrons. Okay, remember this formula. Before getting charge, remember for charge we have this formula, N is equal to Q divided by E. This formula says number of electrons, not number of moles of electrons. Okay, get that correct. So this small n here, it is this bigger n thereof. After getting the number of moles of a number, not number of moles, number of electrons, we can get what? The charge by using which formula? That says number of electrons is equal to charge divided by electron. We know one electron, it is equivalent to what? Okay. Then the fifth step, now that you have charge, you can come then and say current, it is equal to Q changing T. Let's execute those steps. First step, number of moles of a silver. So we're going to use this formula, N it is equal to M molar mass. What is the molar mass of silver? It is 160. I'm lying, 108. So you can come here and say, for step number 1, number of moles of Ag, it is equal to mass divided by molar mass. What is my mass? My mass, it is 3.25 divided by 108. How many number of moles of in total I get? I get 0.03. Now I should compare the number of moles of Ag. It is equal to the number of moles of electron. Why am I saying that? Why? Because check, Ag plus E, it is equal to Ag. The ratio between electron and Ag, it is 1:1. Okay? So hence I'm saying they are equal. Then now remember, but I want the number of electrons. I'm going to say N, which is the number of moles of electrons, is equal to the number of particles in, specifically I want electrons, divided by Avogadro's constant. Okay, so here I have 0.03. This is my second step. This is my third step. Then I want number of electrons, then 6.02 times 10 to the power of 23. If I'm still correct, yeah. Then the number of electrons, or one can I say number of electrons, it is equal to what? 1.81 times 10 to the power of 22. Okay, now that I have that, I can see now number of electrons, it is equal to Q divided by E, or you can just use number of electron like this, or just N. Okay, now I want my charge, but I know what 1.81, this is step number 4. 1.81 times 10 to the power of 22, then I can get my charge, because I know 1 electron, it is 1 times 10 to the power of negative 19, 1.6 rather. Then I get a charge of how much? Of 2.2889.6 coulomb. Okay, then I can come here and see, all right, that's good. That's good. Then how am I going to use this? I'm going to say there for current, for step number 6, I is equal to Q divided by time. Then I can substitute, sorry, not comma. Then my time I was given as 30 minutes, so I will convert to seconds. So it will give me something like 1.61 amps. Okay, normally when you are doing a NSC or you're writing DBE, sorry, you will use this format. But if you're doing IEB, where they use Faraday's constant, they can move from here. From here, instead of doing this one, they can say now Q it is equal to NF. Let me show you what do I mean. After getting the number of moles of number of electrons, they come here, Q divided is equal to NF. They say instead of using this step now, they replace with Q it is equal to NF, where F is a constant, Faraday's constant. Okay, so what is the magnitude of Faraday? Here it is the number of moles. This one is the number of moles. So it is 0.03. Faraday's constant, it is a constant that is 95, 96, 500. We are not given this on the formula sheet. So if you want to apply Faraday's constant, you have to cram this number. Okay, so it gives you something like 2.895 coulombs. Okay, coulombs. Can you see here we had 2889.6, here we have 2895 coulombs. So there is a slight difference Then now you can go directly to Q divided by changing T. 2895 divided by 30 times 60, you'll get more or less the same answer. Okay, yes. So yeah, that's all for electroplating. And remember, the mass in here will increase and the mass in here will decrease. Okay, yes. So thank you very much. That's all for May June 2024 question paper. I hope you enjoyed it from question 1 up to the last question. Thank you.